Hello guys, so we are back again, and in this session we are going to continue with the type 5 type form, which was 1 by 0, infinity power 0 and 1 power infinity. So before starting with this session, hope you have subscribed our channel and don't forget to share it with your friends so that we can bring more engineering content to you guys. Now let's begin with the lecture. In this session, the first question which we are going to encounter is this. In the last previous session, we have saw two questions based on the type 5. This type of question, whenever you see any this type of question which has E, okay, always take log. Okay, always take log. Okay, just don't see the form also, just see the log. Okay, E. The movement first step will be what you should take log. L is equals to limit x tends to infinity, means you this power will be reduced, which will just reduce your job only. So here first step will be writing this sin h inverse x by cos h inverse x. After this, what we will do is that we will substitute. Oh no, we will not taking. There is no need taking logarithm. Taking logarithm on both sides, we get log L equals to, if I take, apply log, by cos h inverse x. Okay, now one more thing, this sin h inverse x and cos h inverse x are hyperbolic function. I am telling you, hyperbolic functions, while this sin x and cos x are circular function. So you should not differentiate. Okay, you can call them natural. Okay, natural sine log. Okay, doesn't matter, but you should know this. Okay, the properties differ. Okay, they are entirely different from these circular functions. After this, I have taken log, then I will move the log inside. The moment I move log inside, this will, okay, let me write this step. After this step, you have to mention the reason. In this next step, you will be left with limit x tends to infinity sin h inverse x and cos h inverse x. You have to mention the reason here. You know the reason, log e to the base e is 1, or anything which has same base. Okay, something, okay, whose m and n are same of log. Okay, it is equal to 1. So here, after this step, we will just substitute, and if we substitute sin h inverse x, sin h inverse x and cos h, if I substitute infinity, it will give me infinity. If I substitute here infinity, it will give me infinity. So we have infinity by infinity, which you can say 0 by 0. Okay, they both are same. So we will apply L'Hopital's rule. We will apply L'Hopital's rule, which give us log L equals to limit x tends to infinity. We know to solve these two, which have standard process, under root x square plus 1, its differentiation, cos hx differentiation will be x square minus 1 upon x square minus 1, and this x square minus 1 will shift to the numerator. Now we will take x outside, which will give me 1 by x square, and here 1 plus 1 by x square. If I substitute here, x and x will cancel out, limit will be there. You have to mention the property of sin x differentiation here, reason. After this, the moment you substitute, this will become 0, this will become 0, you will be left with 1. Okay, which is the required answer. Now you have to write the question and then write it equal to 1, then you will get the complete marks. Let's move on to the next question. The next question is sin x tends to 0 sin x by x the whole upon 1 by x square. In these type of problems, first write this thing, limit x tends to 0 sin x by x the whole upon 1 by x square. After this, if you directly substitute the value, you will get sin 0 by 0, 0 by 0 the whole upon infinity, okay, which is not okay, which is entirely some random form. So never do that in this type of question. Whenever tan x by x, cot, okay, sin x by x, this type of function are given, okay, this is a variety of problem, okay, this is a where 1 by x square, okay, this type, just remember one trigonometric upon a algebraic function. What happen actually is you have to distribute the limits, then you will come to know it's okay, then you will come to know that it is from what type 5. Let's see, let's me first distribute the limits. Now I have distributed the limits like we used to do. In many problems we don't distribute the limit, we can easily make out, but in this type of problems it becomes necessary, otherwise you might get stuck. Sin x by x when x tends to 0, it is a property which tells it is equal to 1, and this will tend to infinity. So now I can clearly make out that it is for form 5. After this, what should be my next step? Taking logarithm on both sides. What we get if we take logarithm on both sides? Log L log bracket limit x tends to 0 sin x by x the whole upon 1 by x square. After this step, what will happen? Log will be there here, limit will be there here, log will, and we will get this log sin x by x. Now we have this function. What many children get confused, okay, this is in the numerator and this is in the denominator. Let me specify. You have to observe it like this: log sin x by x by x square. This is the required function. If now one doubt can be, sir, you should distribute the limit and you will get the answer, this will be 1, this will be 0, but this is 0, it will become infinity, undefined, so you cannot directly substitute, okay. After this, what we are going to do, if you substitute, it will sin x sin, this will become 1, log 1 is 0. If you substitute, you will get log 1 by 0, which is log 1 is what, 0 by 0, which is an indeterminate form, which we always wanted, because in this indeterminate form we can apply L'Hopital's rule. Apply L'Hopital's rule. Apply L'Hopital's rule, we get this is the thing which we are getting here. We will get x square x cos x minus sin x, right, the whole upon 2x. If I substitute what I am having, okay, what we can do, we can distribute the limits so that we don't need to simplify this. If I distribute the limits, I am getting this thing, this and this will combine, and I will be left with this cos x minus sin x the whole upon 2x cube. This will become 1. Let me take the next page. I will be left with limit x tends to 0 x cos x minus sin x by 2x cube. If I put the values, I have 0 minus 0 by 0, which is again indeterminate form. Apply L'Hopital rule, mostly apply L'Hopital's rule, which gives me, if I apply the L'Hopital's rule, what we are left with, we get limit x tends to 0. If I differentiate the denominator, I have cos x minus x sin x minus cos x the whole upon, we have 6x square. Here this and this will cancel out. Limit x tends to 0. We are left with sin x by x. 1x and 1x will cancel out, minus 1 by 6. We will move this outside. Minus 1 by 6 will be here, and this will be sin x by x, which will become 1. This will become, you have to mention the reason in each and every step whenever anything you do. So you are getting minus 1 by 6. Now you will write this question and write it is equal to 1 by 6, and then you minus 1 by 6, then you will get the complete marks. Now let's move on to the next question. Next question, as I have mentioned you earlier, this question can also be asked in the form limit x tends to 0, tan x by x, 1 by x square, or 1 by x. Same thing you have to do. This question I will just directly solve, because if I feel that something is necessary to explain, then I will explain. See, I have distributed the limit like I did in the previous question. After this will become 1, this will become infinity, which is an indeterminate form, type 5. Here I will keep it outside in the first step, then I will move the log inside. This will be come down. This will be log tan x by x. I have done that step directly, which I used 2 steps in the previous problem. Now we are getting this. You know the reason why we cannot distribute it. We will get an indefinite. Okay. we cannot distribute. You will say this will become 1, okay, and this will become 0, which will become 1 by 0, which is infinity, undefined. Now after this you will substitute. Before substituting, this will be 1 by 1, this will be log 1 by 0. This log 1 is what? 0, so we are getting 0 by 0 form. That was I am mentioning that we will get a indeterminate form again. Now, but this determinant form is not this one, it is 0 by 0, which we simplify using L'Hopital's rule. If we apply the L'Hopital's rule, we are getting... Okay, in the last problem, I forgot to mention one thing. I think in the last problem, okay, this one, I forgot to mention one thing. Here it is log L, and we are getting 1 by 6. L will be e power minus 1 by 6 in each problem. Then you have to write the question and then place it is equal to e power minus 1 by 6. Log L, what I am getting, we will be left with tan x. Here it will move, and if we distribute this, x square x square x minus tan x, the whole upon 2x. If I distribute the limits, I will get rid of this, and I will left with, this will become 1. I will be left with limit x tends to 0, x square x minus tan x, 2x cube, log n. After this, what we are going to do, we are going to see, if I substitute here 0, this will be 0, so it is still 0 by 0 form. Apply L'Hopital's rule. If I apply L'Hopital's rule, what we get? We get sec square x plus 2x sec x dot sec x differentiation sec x dot tan x minus sec square x tan x differentiation the whole upon 6x square. If you see this and this will get rid of, and this xx will Finally we will be left with 2 sec square x 10x 6x. Limit x tends to 0. This will become 1, this will become 3. We will move the limits, we will distribute the limits. In short, sec square x, limit x tends to 0, 10x by x. The moment I distribute the limits, this will be 1 by 3, which will be outside. What we are getting here, this will become 1, this will become 1, so my answer will be 1 by 3. Now this is not the complete answer, we have log L here. It will become e power 1 by 3. Now you have to write the question and write it is equal to e power 1 by 3. You will get the complete marks. Okay, and don't forget to mention the steps. Okay, reasons. Now let's move on to the next question. Next question which we are going to do on this is this question. Limit x tends to 1, 1 minus x power n, 1 upon log 1 minus x. First thing, write this, the whole upon log 1 minus x. After this substitute, you will getting 0. This will become log 0, log which is okay. If you substitute the value, you will get 0 by 0 form. This will become what? This will become 0. Log 0 was minus infinity. This will move on. Okay, it will become 0. So we are getting 0 by 0 form. What we are going to do is, since it is from type 5, our steps will be same. Taking logarithm on both sides. Log L equals to log bracket, right? Limit x tends to 1, 1 minus x power n, 1 by log 1 minus x. After this step, limit x tends to 1, it will become log 1 minus x log 1 minus x power n. If I substitute the values, this will be 0, which will be minus infinity by minus infinity, which is nothing but infinity by infinity, which is an indeterminate form, as I mentioned. Now 0 by 0 or infinity by infinity form whenever appears, we apply L'Hopital's rule. L'Hopital's rule. If I apply L'Hopital's rule, I will be left with what we are getting. Minus n x power n minus 1. Here we will get 1 minus x. This will be minus 1, which minus 1 will simplify. We are left with if I put the values, what I am left with, this will be 0, this whole thing will become 0, and this is still 0 by 0 form. What we are going to do, apply again L'Hopital's rule. What we get, we will apply product rule, which will give us n into n minus 1 x power n minus 2 into 1 minus x plus n x power n minus 1. This will become minus 1, the whole upon n into x power n minus 1, which will, if you substitute the values 1, this will become 0, entire thing will be gone, this will become 1, and this will be 1. So we are left with finally n into minus 1 minus n into 1. This will cancel out, minus minus, we are left with 1, which is log L. So my final answer will be E. Now you have to write the question and mention it is equal to 1. You will get the complete marks. Let's move on. let's move on. Okay, in this next session we are going to continue with some more problems. Okay, these much questions are more than enough for this session. In this session, next session, we are going to see some more problems on this type 5, and then we will move on to the next. Okay, finding the constant from the limit type problems. And if you have not subscribed the channel, please subscribe the channel so that we can bring more content like this which can help you boost your academic score. Thank you. See you in the next session.